Hello and welcome to this PV Magazine webinar, The Upside of TOPCon, High Efficiency, Low Degradation in Mass Production. My name is Blake Matic, I'm an editor at PV Magazine, and I'm joined today by my co-moderator, Bella Peacock, an editor at PV Magazine Australia. The past 18 months have been a turbulent time in PV manufacturing, well, for everyone, of course, but it's also been a time of impressive developments, particularly in the production of N-type solar cells. With PERC cells reaching the upper echelons of improvement, we see more potential in the improved efficiency and reduced degradation, particularly in regards to LETID, in N-type tunnel oxidative passivated contact, otherwise known as TOPCon. Chinese manufacturer Jinko Solar is one of the major TOPCon converts and is betting on the technology as the company looks to transition to high efficiency lines from the dominant P-type to N-type. The testing ground for this transition looks as if it could be Australia, where Jinko is planning to massively increase its shipment of N-type products. Thanks to Australia's thirst for new technologies and its advanced utility scale market, the country is ideal for Jinko to prove its technological developments at scale. So, what promise does N-type TOPCon hold, and why is it particularly useful in Australia's hot and increasingly humid climate? To discuss these questions and more, we are joined by three presenters today. Dan Su, Technical Service Manager at Jinko Solar Australia, Aaron Bonanno, Principal Engineer, GSES, and Dr. Mark Griffith, Power Generation Practice Leader at Oricom. And now I'll throw to my co-moderator, Bella, for some quick housekeeping before we begin. Bella.
Hello, everybody. We just got to cover a few kind of basic things before we continue. Firstly, at any point, if you can't hear us or any of the speakers, please let us know with the Q&A chat function on the side. We'll be keeping an eye on it. So if there's any kind of technical issues there, you can also use that, that kind of function to flag that. We are recording this webinar, so you will receive a link at the end of the event with a recording. It's sent to every registrant. And finally, I would really like to encourage you all to get involved. We will be finishing with a Q&A section at the end, but you don't need to wait to kind of pose any of the questions. We'll be keeping an eye on that Q&A section, and we'll be introducing some questions throughout and also keeping track of them for the end. So yeah, if you have any questions, send them through. And in response to a question we always get, yes, these slides will be available afterwards. That's enough from us. I'm going to hand over to our first presenter, Dan Su, the Technical Service Manager at Jinko Solar. Dan, over to you.
Yep. Thanks, everyone. Hope you hear me all right. And thanks for coming today and joining us in the new year. Yeah, I think we can save the cliche about that company introducing about Jinko. So hope you all know us, and hope you can get to know us if you haven't. So Jinko has been leading in the manufacturing of solar modules, and especially in Australia, we are positioned as the #1 manufacturer of panel suppliers. Jinko is a very technical-driven company. That's why you keep seeing new products coming from us. The question has always been, why are we choosing the N-type and what's coming in the next, right? So there's a little bit background here. If you've seen the technology in the past 2-3 years, you'll be amazed, right? 2 years ago, I'm still working as a project engineer. I'm still working with like 270s, 260 modules. And now we suddenly talking about 500, 600 watts. So it's a quite amazing improvement, but there is a threshold that we are hitting. So on the current P-type PERC technology. So if you're aware, the climbing of the efficiency has actually been slowed down for the current technology roadmaps of the P-type PERC. And it's hitting the caps of 24.5 of the theoretical maximum efficiency. Where in the parallel, Jinko in the 2 years, within the 2 years time, we actually launched a new product that is called N-type. So N-type itself is not a very old concept, but the most important thing for it is it has a great potential to reaching high. So in theoretical, the N-type top and with the TOPCon technologies, it can potentially go into a 28% or over of efficiency. And currently we are sitting around 25.5, which is already over the PERC. And that we can introduce in a module level of a 22% of efficiency to really revolutionize, the game of not just the power, but more on the efficiency wise. A little bit background of forecasting on the N-type. We can see it's definitely coming as a trend. I think it's similar to what we had before from changing from the poly to monocrystallized. So from different sources, we'll see the forecasting for the N-type will definitely grow in the next 2-3 years. So it is very, very, very fast, similar to what before the mono has taken over the poly in a very short 5 or 10, longer 10 years period. But we're looking at the N-type will be growing from the currently just a small share, 5%, but to massive of 20-30%, while the pricing gaps in between N and P is getting much smaller. So Jinko has been doing the smaller size, the N-type, our Tiger series for 2 years in Australia now. It's been a very successful product. We had 370s and 390s coming in with the 163 millimeter cells. And now we are upgrading the whole thing into what we call the 182 millimeter wafers. And Jinko has been introduced this year a 10 gigawatt of product capacity. This is across the industry, and a lot of companies are also looking to this direction, and we are obviously ahead of it. So just a little bit more technical. Hopefully it's not too boring, but there are a couple technical roles in the market that you have seen: TOPCon, PERC, HJT, or HID. Well, the reason in choosing the TOPCon is really for the transformation from our current existing products. So what we're looking for is something that is reliable, that something has been tested, and can be easily transformed from our existing product line and into, and over the end of the day, what we're trying to deliver is a product that is cost efficient, but it also is amazed with good efficiency, good bifacial factors, good temperature coefficient, and good degradation. That those are all the known benefits of N-type over P-type products. So that's actually looking at the products. So what is coming here is not just the so what we're looking at is a couple new products. So the 78 products, 78 cells and 72 cells. It comes with monofacial, bifacial. If you know our products well, you're seeing they are actually similar to what we had before. Well, you're right. The physical size of the module is exactly the same. The electrical are similar. You're looking at a current of less than 15 amps, and you're looking at a voltage around 55 or 50 that allows you to do 28, 29 modules per string. So essentially, they're not in the module level design-wise, they're not so different to our existing P-type. So that's why you can just swap in between a project. If you have a project, you can just swap in between the P and N quite easily. So the 72 will offer a power class from 550 to 570, where currently we're delivering 560. Where the N-type we're looking at around 600 watt at the moment. So they will be available in dual glass and also in monofacial. Where in the residential market, we're still very strong pushing on this 163 series. So it will be available, continuous available for the 370 watt, but we also launching the new 115 for upgrading from the previous 390 watt for the same physical products. We're in the newer series, when we're calling it, we are going to have a 54 cell format. That is one more compact, only 1.7 meter tall, and also upgrading from our existing 440 to this. I think it's a flagship of the 470 to 470 watt. of 182. So within that 2 meter, within that 1.9 meter tall, not going too crazy, but you got a decent 470 watt. So all of this will come with a special warranty for Australia. We're looking at either 20 or 25 years of product warranty, and 30 years or 25 of product performance warranty. That is exclusively to Australia. So briefly talking about advantage of what are the differences of N-type. So we have really 5 points that we think it's important. The first one will be looking at the degradations. So degradation is quite important if you are seriously running your generation curve over 20, 30 years of lifetime, right? So your module, once it's exposed to the sun, it starts to degrade. That's called the LID, so light-induced degradation. So if a normal P-type or older generation, you'll be looking at 2% or even 2.5% of LID losses the moment you really open the boxes. Well, for the N-type, it has a great potential to work against it. That's why we're giving only 1% degradation warranty for the first year, where the linear warranty has been reduced from previously like 0.6, 0.7 to now 0.5, and now it's as low as 0.4 for every year. What essentially means that over the lifetime of 25 years, well, not even the 30 years, so we're looking at a 23% upgrades on your generation for over time. Where the second adventure will be temperature. So the game of in Australia, we know it's a hot and humid, so temperature coefficient becomes key points for in our system design. Where previously we're looking at 0.35, and now it's dropped to 0.3. Although it doesn't seem too much, but when you're actually running a whole year of simulations, you will quickly figuring out, yeah, the actually lift from this temperature coefficient is quite significant, especially given a very hot temperature. If you're looking at like it's the 1% or 0.5% upsizing just because of this 0.05% of difference, where we're still continuing to improve it through a different combination of technologies that including different design in the bus bar, different design in this back sheet, selection of back sheet glasses, so all, and how to reducing the heat of the modules and reducing the working temperature. The other key uplift for the N-type will be the bifacial factors. So if you're working with the bifacial projects, you immediately know, so a current bifacial product will have 70% of bifacial factor. That means it gives you around 1% or 2% of bifacial gain over a year, where the N-type will give you the additional from due to the natural of it has a better bifacial factors, right? So we're having a bifacial range of 85%, but also the generation will be, although it will be heavily depends on your albedo, but we're probably looking at around 11% of uplift if you compare to a non-bifacial P-type products. So this other one will be low light performance. So that's mainly due for the beginning of the day, that where your ingredients is lower than 600 watt per meter square, and also for the afternoon. That so you're looking at the curve is more flattened out over the year, especially within the bifacial, and that helps to actually rethinking about the AC/DC capacities, the ratio for your modules to actually benefits your performance. So like I said, we also have some small innovations like multi-bus bars, circular bus bars, tiling ribbons. All of these we have talked in the past that helps to improve even just a little bit. That's why you will see a comprehensive module design that is allowed for 22% of efficiency, with combine all this little improvement and innovations. So for Australia, Jinko is the one that is very strict on what kind of backsheet that we're using. So for this Tiger Nuance, we do apply tabular backsheet, and it is very important that the backsheet does not crack or does not degrade easily over years of period. We have learned the lesson from the previous, and all the products you've seen currently selling to the market will come with either Tedler or backsheet, like a good backsheet like a POE. But there's also other innovations such as selecting different colors of the backsheet, adding a different layers of reflection layer, so that improving the front powers to another 5 to 6 watts. Overall, to improve the performance of the module and efficiency. Right. So all of this can be imported into your PVSys or some simulation software. So making sure when you are actually selling these kind of products, you should be looking into these product details of what are actual uplift from each sectors. The other, I think, so that's why we have invited GSES and Arcon today. They will introduce us a little bit more into this engineerings. But for N-type, you should be really thinking about a balance of the AC and DC. So to utilize those uplift from the generation, not just looking at the peak power by itself. Lastly, there's all this couple. So the reason there's always questions like, is Jinko going to step into the 210s, or are we sticking with the reason we're choosing 182? Is simply because we think 182 at the moment is probably a better solution as a module wise, right? So it fits into the container, it fits into the tracker, and it would apply for a better engineering and electrical design that allowed safety in the designs. For the time pressing today, I'm probably not going too deep into it. But if you have any questions around it, I'm happy to explain them in the Q&A. So just a quick summary. So here, that's what we're looking at for the New Year's. So you get the 72 cells, 78 cells, and 60 cells are also the 54 cells in a different format. So Jinko would produce all these into 2 different scenarios. You're probably looking at the 54 for residential, 60, which is quite a limit of what size can go, but also it's great for commercial. Where the 72 and 78 will be the go-to products for your utility projects. And the bifacial will be a very interesting topics, not just for utility, but also on the rooftop that we are exploring at the moment. Well, thanks for having me for now, and I'll pass it on back to.
Thank you, Dan. That was a lovely presentation. We've already got a raft of questions coming in. As we said at the beginning, keep those questions coming in, guys. Those are great. We'll do a larger Q&A at the conclusion. In the meantime, I'll try and just pop a few of these, maybe 1 or 2 of these to you now, Dan. You, at the end, you covered what is probably a question a lot of people are interested in at the moment, which is basically just module size. Jinko is a firm believer in 182, and you mentioned some things about transport costs and things like that. Could you expand on that a little bit of just why 182 is the preferred option?
Yeah, so we'll be looking at a couple of things. I think mostly for utility projects in Australia, just domestic and utilities. For the domestic sector, we really believe the size at the moment of 1.9 by 1.1, it's really the maximum that people can handle. By one hand and by one person. Anything go beyond that will be a very big challenge. But that is also, we have a smaller product, a profile like 54 cell, it is only 1.7 meter. Not just pushing for bigger power, but also consider how people would handle it in a real situation. For the utilities, our choice for 72, 78, it's more about tracker compatibility and also maximize the bifacial factors. So in Australia, we have seen 100% of projects, well, 90% of projects are going with tracker. So compatible with tracker is actually very important for us, where the current 78, the 182 is really just an upgrade from our previous, the 72 that you're all familiar with, right? The 2 by 1 meter. So format wise, it's not crazy. It still can be very good handled by 2 people without any safety issues to install to the tracker. And for the tracker, we do see a physical limit of like 100 meters or 60 meters for the 2Ps, around 100 meter and for the 1P. And within the physical limit, then we can talk about, what is maximum power per tracker. And given that, I think in short, when you actually consider all these factors, you will immediately see the higher efficiency is what helps to reduce the cost on the BOS and what helps to improve your LCOE by giving you that 2-3% additional every year of generations, right? So not really just for the higher power, going for 700 watts, 800 watts with just the 21% of efficiency doesn't really help with the overall BOS. Where the actual improvement in the technologies, in the efficiency, that helps to save on the BOS, and what most importantly is to give you that extra generation of 1%, 2%, and it definitely worth the investment for a little bit high, and it can recover it in 2-3 years time easy. Yeah, hope Wonderful. That's good enough.
No, certainly lovely answer. Very thorough. We've got a lot of questions coming in, which is good to see. I think I'll save some more of them until the end so we can have a proper in-depth discussion between the group. In the meantime, I will throw to our second presenter, Aaron Bonanno, who is a principal engineer at GSES. Aaron, take it away. Joining us from Sydney, I believe.
Thanks a lot, Blake. Yes, based in Sydney, a bit wet out there today. Good morning and afternoon, everyone. Welcome to the PV Magazine webinar, and thank you, Dan, for presenting so far on the Jinko product. So I'd just like to start with a welcome to, or a acknowledgement of country. So here in Australia, GSES acknowledges First Nations people of this continent, the lands on which we will live, work and play, and recognise their continuing connection to land, water and community. We pay respect to elders past, present and emerging, and Australia and Sydney GSES is on Gadigal land. So just a little bit of an introduction to GSES for those of you who may not know much about us. We are an internationally recognised engineering consultancy. We provide education and training in this industry. We're an independent resource, uniquely placed to provide unbiased advice and engineering services. We actively partner with government, private enterprise, local communities all across the world to facilitate the introduction, development, and growth of renewable energy technology. So the hope for today is we can provide some unbiased advice looking at the following topics. So we're going to compare a couple of different modules in a 500 kilowatt commercial size system, look at some of the considerations with the recent Australian standard update for 5033 using the new Jinko panels, and then some specifics related to that that we think need to be sort of called out in terms of installation and how things may need to be balance of system components that may need to be considered moving forward as modules increase in size and in capacity and current. So firstly, this 500 kilowatt system performance comparison that GSES ran, we looked at two different modules, both the same performance capacity, but just different types. So one was a P-type module and one was an N-type module. And you'll see here, it's pretty clear just straight off that the N-type module has a higher performance ratio and production overall. So this configuration offers about 5.6% better performance than a P-type module. So yeah, I was a bit surprised by that. I didn't think the percentage would be as high. So we just designed a fairly common commercial installation, a couple of different orientations, flush mounted to a roof in a hot climate. And yeah, this is the numbers that we got out. So Interestingly, if you just sort of think about this on a smaller scale, just using some of the specific production numbers, this equates to about $100 a year saving for a residential customer if you went from P-type modules to an N-type module. So you're using an N-type module, you're potentially saving, giving your customer a $100 extra saving per year. So diving into this a bit more to look at why this is the case, similar to a lot of what Dan said, actually. So you can see here that the IAM values, which is what's called the instant angle modifier, which is effectively a measure of how the module absorbs light. You can see for the N-type module, that is a bit higher. You're actually getting a bit better gain there. And the temperature power coefficient is, what does that mean? If you, go down a little bit there, you'll be able to see the potential temperature power coefficient is actually a bit lower. So we're actually losing less even at the same temperature. So the N-type module is extracting more energy more efficiently, and it's not heating up as much. It has slightly lower module degradation, and the power temperature coefficient there, we can see that we're actually extracting more amount of energy from the same solar resource. So now we're just going to have a brief look at just some changes to 5033 and how this might impact on your designs for commercial industrial systems. So the standard is now compulsory above 240 kilowatts, where before it was optional. So that means that even larger systems still have to comply with the standard. We've got an increased voltage allowance for residential systems for 1,000 volts, and then for commercial industrial 1,500 volts, which has been fairly common still already. And then the other big one, Dan mentioned bifacial modules. We haven't looked into that in detail, but there's been some changes in the standard about how that is actually taken into account. And from what we understand, the guidelines or CEC will be releasing an overview of the adjustment factors for bifacial modules, I think soon. Oh, sorry, not the CEC, IEC. And that will provide some guidance there on how to actually account for bifacial modules and the extra current in designing a system. So just have to keep that in mind. And that'll also feed into what I'll be talking about next. The last sort of major update that I just wanted to bring everyone's attention to was updates to DC isolators. So just depending on how your strings are configured on your roof, you do or don't have to have DC isolators. It also depends on if you have fusing or not. So this can impact your balance of system costs. So we're finding that the most efficient way to really run a commercial system is to really run and to sort of minimize the balance of system is to run individual strings as much as possible all the way back down to the inverter. And a lot of new inverter products these days allow that with lots of different maximum power point trackers that you can connect your strings into. And also just wanted to touch on, so sort of taking some of those considerations into account here, just we've used some of our analysis tools to really compare string sizing for different configurations. So taking into account sort of D ratings on cables for different currents, and because modules are producing more and more current, and this is especially important for bifacial panels. You can see here, so the first three lines where we're just looking at different string configurations and cable sizes. And then the last line here is looking what would happen with fusing. So if we include fusing in our cables, and Jinko uses a 25 amp overcurrent protection rating, and we've just assumed a fuse of that size. So on the first line here, we're saying a standard 4mm cable, just in a single string by itself, and that's running along the roof with 11 other circuits, including itself. And we're seeing here that our D rating is actually higher than what the current flowing through that circuit would be. So we would actually have to upsize the cable or downsize the number of circuits in parallel. So if we reduce this to 10, we would actually be able to run 4mm cable, or if we wanted to keep them all bunched together, we'd have to upsize to 6mm cable according to the standards. So that could have implications on how you run your cables back in cable tray on a roof, in conduit underground, or sorry, these numbers will be slightly different for underground, but different things to consider there. The second and third options are also the same as well, but I've just put 2 strings in parallel rather than a single string. So in traditional cases, we may have been able to run a 6mm cable for 2 strings in parallel. But again, because we're getting higher currents, we're really limited to the total number of adjacent circuits we can actually run in parallel there. So when I say parallel, I don't mean they're all carrying the same current. They're just cables next to each other. So they're potentially transferring heat and causing derating in that sense. So when we look at that, we can actually only run 4 adjacent circuits next to each other using a 6mm or even a 10mm cable that's carrying 2 parallel strings. So again, according to the standard, we can remove our rooftop DC isolator with two circuits in parallel or less. So this again is sort of allowing for no rooftop isolator, but it limits the number of circuits we can put next to each other. Then the last option here again is just looking at what happens if we use 25 amp overcurrent protection. So again, because we have to consider the D rating on the cable, even just with 1 circuit in parallel, a cable by itself, the most we can have in parallel is 4 circuits. So again, we're pretty limited in terms of what we can do here. Yeah, I meant to say the most we can have is 3 circuits, so 1 less than this value here. But if we wanted to use 4 circuits, we would have to upsize to a 6mm cable. So yeah, just different things to consider when we're looking at balance of system components and how we actually do a design. So I hope that's helpful in terms of using these more efficient, higher current modules when you're thinking about what sort of inverters to use and how you're going to run your strings down off a roof. Just keep these sort of things in mind so you can try and limit the cable size that you're using, so you're reducing some of your costs in cabling or cable tray. And that brings me to the end of the presentation.
Excellent. Thank you, Aaron. And also some excellent moderation from you right at the top there. I thought, wow, Aaron's doing my job better than me.
Sorry about that, Bella.
Thank you so much for that. We've still got a whole bunch of questions. I might wait until the Q&A section so that we can kind of direct them to everybody. So I would like to introduce our third speaker for today, third and final, Dr. Mark Griffith. He's the power generation practice leader at Oricon, and he is joining us from Brisbane. Mark?
Hey, Bella. Yes, I'm joining from a very sunny Brisbane. I think that everyone working from home is keeping the solar industry very happy. Everyone's running their air cons, and I see we're hitting some pretty high wholesale prices. So it definitely is reflected in the temperature as well. I'm going to do something slightly different. So I'm sharing my screen. Just let me know if that is going to come through okay. You can see the intro slide.
We can see the intro side, but I can still see you.
Interesting. Okay. Let me see if that works now. It's not a full screen yet.
Just then it swapped between. Oh, here we go. Yep.
How we looking there? Is that better?
This looks like the first slide of your presentation still, but we had a minute where I could see your screen.
Okay, I think it's supposed to be just the first slide of my presentation.
Perfect. Then we're all good.
Then we're off. Okay, thank you. So my name's Mark. I'm part of the Oricon team. Oricon's a design, engineering, and advisory company that brings ideas to life to create a better future for people and the planet. We're a diverse, multidisciplinary organization. We're active in several markets across several industries, including power generation, and I'm part of the power generation team in Brisbane. In terms of what we're up to, here's some of our recent solar PV project experience. The Bowman Solar project is a particularly interesting one today because that's when I was first introduced to Dan. With Dan's help, we delivered probably one of the largest bifacial utility scale projects. I think definitely the biggest in Australia at the time and one of the biggest in the world. So pushing the envelope from innovation and kind of heralding the new age of bifacial modules. So it's pretty cool to be a part of that. We're also currently working on several other large projects, including 2 here in Queensland, the Coolambulla Solar Farm and the Western Downs Green Power Hub. Yeah, both very exciting projects to work on. Probably just to add, our team is not, well, we are technology agnostic, and so we're looking for the best solution for each application. So when we come to talk about N-type, this is something that we see as an exciting innovation, but it's not something that necessarily are wed to, or we aren't paid by Jinko in any way or form in this case. Just maybe giving a bit of context on how the solar industry is looking in Australia. Large-scale projects are facing increasing pressure as the penetration of renewables rise. We're looking at competition from other solar generators during the peak solar periods, including the residential rooftop market, which is growing at a very, very strong rate. We're seeing reduced wholesale prices and even negative prices. In fact, if you look at 2021's data, you'll see some months where the average hour in that month was actually a negative price. We're also seeing increased curtailment of solar generation. And so the other part is that as renewable levels rise, we have to be integrating with additional firming technologies such as battery energy storage systems. And that will also be looking to add costs. So lots of pressure in terms of keeping costs low. I've got the duck curve here. This is not actually the duck curve from a demand perspective. This is the price duck curve. You can see it closely tracks demand with very low prices during the solar window. It's a bit more. It's not all bad news though. We expect levels of variable renewable energy to continue to rise as coal generation is retired, and as we see moves towards decarbonizing the electricity grid. We're expecting to double our current levels of renewable energy by 2030, and about 60% of that is expected to be made up of solar. This is not accounting for us positioning ourselves as a global hydrogen supplier, which will be additional generation to meet that particular demand. So basically, in the long term, we do have some price pressures now, but it's quite competitive and looking quite strong for the solar industry. But we need to keep innovating because we want to keep generation costs down because we want to have reasonable prices in the future as well. That brings us to N-type with TOPCon PV cell technology. And this is one of those innovations that we need. We've obviously been through the kind of the core benefits with Dan's presentation, but I'll summarize them again here. We're looking at inherently better cell efficiency. We're looking at better bifacial conversion factors, minimal light-induced degradation, and then light and elevated temperature-induced degradation loss, enhanced temperature coefficients, better low light performance, and reduced long-term degradation. And we're looking at a very strong uptake, expecting 50% of the world's PV market share by 2030 with these with the N-type TOPCon technology. And then coming back to Australia, for those who aren't aware, Australia is actually a really hot place. We often see temperatures well in excess of 30 degrees through summer over a large portion of the country, and this is can be particularly challenging for solar technology, especially when it comes to light and elevated temperature-induced degradation and temperature coefficient issues. So, taking the benefits of TOPCon back to N-type TOPCon back to more practical sense, we see improved capacity per unit area, and so we would expect reduced installation and balance of plant costs. If we're installing fewer PV modules, we'd have reduced tracker costs and reduced installation labor. That's also particularly important when you think of it from a health and safety perspective. Working through very long hot summer days, we want to have the most bang for our buck with regards to the labor. We also have smaller plant footprints, which means we have less land required and shorter cable runs, resulting in more savings there. We're also looking at improved system performance. So we should get more megawatt hours per more megawatt of peak and more revenue. And that's due to the improved performance at high temperatures, the bifaciality uplift, and the reduced degradation long term. And another benefit comes down to increasing our confidence in our PV yield analyses. And so you saw the PV-Syst energy waterfalls earlier. The benefit here is if you have a smaller number to start with, then the uncertainty around that number is also less. And so we can have lower LRDs, reduced TRD risk, and reduced lifetime degradation, which should all mean reduced model uncertainty and better outlooks from a financial modeling perspective. This will help more projects achieve financial close because you can be more confident in banking that future generation in your financial models. And in the long term, we're expecting N-type TOPCon PV to reduce installation effort, reduce costs, and improve project performance in our challenging environment. And just to share some final thoughts with everyone, this particular slide has been, let's call it an inspiration for me recently, where at the moment we're looking at the electricity sector in terms of decarbonisation focus, but we have a long way to go in terms of decarbonising the entire energy base. Electricity is only a part of that, and so we've all got a lot to do. PV has come a long way. We've seen production increase from 500 kilowatts per annum to over 120 gigawatts per annum. Numbers are staggering. Over the last 10 years, we've seen 50% improvement in module efficiency, 16% year-on-year cost reductions. And these are exceptional figures, but we need to press on. We've still got a long way to go, and the world's counting on us as an industry to keep innovating and keep pushing the envelope if we're going to meet our future energy needs. And that's all from me. Thanks, everyone.
Thanks for that, Mark. Lovely presentation, and good to see that we've had questions are continuing to come in. So we're just going to jump straight into our Q&A section now. We have a solid 15 minutes. So I'll start with you, Mark. And one question that that popped up with your mention of hydrogen and green hydrogen is that Queensland is probably going to be, along with Western Australia and perhaps Tasmania, have been touted as some of the most promising states in Australia as for green hydrogen export potential because of the obviously solar irradiation in one case, or Tasmania's got its own talents, one should say. But how much do you think improvements in efficiency and degradation with, for instance, N-type modules and cell improvements, particularly in Queensland, where you've got humidity and heat to deal with, a big step forward in Australia's green hydrogen potential?
I think that in general, we need to see very competitive solar generation and N-type TOPCon is one of those examples. But at the moment, we need to consider Australia's hydrogen industry as, let's call it a global, it's competing in global markets. And so energy generation, especially with regards to electricity grid, is kind of limited to that particular area. And the prices, what the generation price is, at the end of the day, you can't do any better. Hopefully you won't do worse. But when you think about it from a global scale, you're now competing with whatever those other countries are able to do in their own countries and in their own areas. And so having technologies that manage through Australia's harsh environments will be beneficial, because it allows us to remain competitive on an international scale in terms of energy supply going forward.
Wonderful. And how about, we have a question coming in. This one's, I think, for you, Dan, and it comes to your mention of albedo in your earlier presentation. The question asked, how much will albedo improve efficiency? Obviously, in your presentation, I think you showed an approximate 15% efficiency improvement in bifacial compared to PERC. So I guess the question's getting at, what's that swinging influence of albedo in those calculations?
Yeah, albedo is there's a lot of things to dig in. So first is, how do we actually define albedo? So it's a bit difficult when you have a huge site and your environment keep changes, right? In the summer you got grasses, and in the winter you have nothing. During construction, it's full of soil. So for the field, we more generally looking at albedo around 10 to 15%. That's more realistic. Grading, okay, so the question is, so changing from 15% to 20%, you'll definitely see a great improvement of generation. So theoretically, if you're going to above like 30% of albedo, your bifacial uplift, just on the module level, you're probably looking at a 20% or like in a power uplift during the peak times. Yeah, but so that's why it's quite interesting to see on the rooftop people trying to improve this albedo by just optimizing using the the reflectiveness of the steel roof, or just paint it white. That actually improved the albedo to maybe a higher level that actually helps the bifacial generation to another so 10% as per the module level, but in the overall generation of the year, you maybe have 1% extra. Yeah.
Oh, that's interesting. Just paint it white. Dan, I got another question for you. If LID losses are non-existent in TOPCon, what factors constitute the first year of degradation, which is sitting around 1%?
Yeah, so when we design the warranties, we not only looking at LID, we do look at a lot of aspects. So we tested the module, through what we call the acceleration test. So there's heat dumps, heat thermal cycles, LID, LETID, PID. So all of things need to be considered. And LID, when we say it's low, we never say it's free. There is still like a very small portion, like maybe 0.05. To be honest, I think that in reality, your module probably will be doing better than 1%, but it's a bit hard to control individual modules. So overall performance, we're giving it as 1% degradation, which is a manageable warranted value. But that's also considering other losses during manufacturers, small chips and scratch here and there. Which will not have huge impacts on the performance, but we're giving some tolerance that they are allowed, to have some kind of these losses from during the transportation and installations.
Lovely. I think a question for you, Aaron. Very interesting to hear about the testing and modeling you did, and $100 saving annually for a residential consumer. I mean, an avocado in your pocket just based off the panel is pretty amazing. Did you extrapolate these findings to utility scale? Or how did you kind of view these results?
No, that was just based off the results that we got for that simulation. So Yeah, it might not necessarily apply directly to a residential scale or utility scale. So I said we did look at flush mounted panels in 3 different orientations. So this was just sort of estimated based off the specific yield that we got for the N-type module over the P-type module, and it equated to about $100 saving, based off roughly a 20-cent kilowatt hour tariff that you would be offsetting. So it was sort of just pure numbers, but just sort of, giving a rough estimate of how much a customer might be able to save per year.
Mm-hmm. And I think based off maybe some insights you had from the various orientations you chose, you might have something to say about this question, but it's also open to everyone. The question comes in: for hilly areas where different orientations are required, will TOPCon N-type PV modules be more advantageous? So I guess, obviously everything's case dependent and size of module dependent when it comes to how undulatory a region is. But do you have any insights on hilly areas and orientations?
Yeah, that's an interesting one. To be honest, I'm not quite sure. I think it would depend on the how hilly it was, and I guess what sort of inverter you would be using really to see how you would configure that, and what sort of tracking system you were using, fixed versus single axis, because that would definitely have a large impact. But I'm imagining if you were using a fixed tracking system that you could space out across the hillside, everything would be at a pretty standard tilt. So the orientation might change a bit, I guess, depending on the way it slopes. But I don't think then that would have a huge impact because everything would be sort of very similar. There might be some comments to be made around bifaciality. If you're on a hill, maybe there's some improved albedo because of the slope of the hill. But yeah, that's a bit outside my wheelhouse.
Unless either of Mark or Dan wanted to add to that, this is a question that I think we could also kind of throw out to everybody. It looks like there's a lot of advantages to N-type modules. Are there any disadvantages? Perhaps the cost?
Yeah. Well, we'll be very open and transparent, as cost is the biggest challenge, because like any new products coming into the market, there will be a small gaps. But keep positive. The beneficial as we're seeing at the moment can definitely overcome this little gaps in the cost. That's like I said, your investment in the projects, you'll probably be looking at 100 megawatt. You're probably looking at a couple million extra. But given that you got 2% of generation, even 1% of generation added, this value can be easily paid back in very short periods, like 3 to 5 years. So that also applies to, like said, Aaron said, $100 per year. It doesn't sound much, but when you actually look at the scale of the project, 6 kilowatt, you pay $2,000. You pay down $3,000, $4,000 for it. And by paying investing in additional, $200 to $200 in the beginning, and guaranteed $100 per year, that's very good math, right? Yeah.
Very good. And there is, I guess, what's so promising about the N-type modules is this, space in the ceiling for these improvements, because we're, already approaching PERC prices. One question came in regards to the big issue of high silver prices at the moment, and that being, certainly a problem for HJT. And I believe Jinko has, is quietly confident that it can reduce its silver consumption levels. So what kind of improvements can be found on the pure ingredient level?
Yeah, so we do have a couple small improvements over the year. I think the silver are mostly used in bus bars. If you're looking at our bus bar design, we had 5 bus bars to what we call 9, 10 bus bars. And the new generation we're introducing what we call the SMBB, so it's a super small multiple bus. So the size of the cylinder keep getting smaller to allow you keep the same current to go through, but you will be allowed a smaller consumption on the silver to having all this, but also on the smaller usage of coverage on the cells to allow it less shadings on the, within the cell itself. Yeah.
And we just kind of building on that then, we got a few questions about kind of the difference between TOPCon N-type and HJT, so heterojunction technology. Could you provide maybe a bit of just a quick comparison there in terms of, because we looked a little bit at the comparison between PERC. Did you have anything to speak on that?
Yeah, I don't think we will get deep into too much in the detail, but in the short, from manufacturing or mass production point of view, so HJT does have, when we're talking theoretical value, they do provide a slightly better top efficiency, and in some aspects it doing better, such as temperature coefficient. But on the other aspects, like they each have their pro and con. What Jinko really appreciated for TOPCon is how easily it can be transferred from our existing PERC. So the initial investment into the technologies, upgrading from the existing product line is pretty straightforward for ourselves as a manufacturer, right? So that allowed us to have an internal capacity to produce the N-type cells and to the modules, and that line can produce both P-type and both N-type products, depends on what we need. So instead of creating a brand new line to just having the HJT, although the HJT itself does have a slightly easy, production process compared to the N-type, but adding a little bit extra steps in the current P-types, well, for us, it just makes more sense from the mass production point of view.
Wonderful. And I think we have time for one last question, which I will throw to you, Mark. You mentioned that you worked on the Columbulla farm, which connected to the grid or began its grid testing phase last week, I believe, which is fantastic news. So I thought I'd get a gauge from you about how you think the utility scale sector is responding to the new modules in Australia, how Australia shapes as a market for the introduction of these modules on a global scale.
I think the Australian industry has shown itself to be quite receptive to these new technologies. And when you think of yourself as an owner, you making your one decision that'll last you 30 years, and you could either enjoy that decision or regret it for 30 years if it proves to be the wrong one. And I think that's what we are seeing, is that the market is receptive to these new technologies. We're seeing bifacial basically a standard now, whereas projects that I started on 3 years ago weren't even considering bifacials. And so I think we are seeing let's call it a market that is receptive to these developments. It doesn't mean that we're going to be reckless. We still need comfort in the underlying processes, and having let's call it the nuts and bolts of how the production line is changing, for example, is something that gives us comfort when we look at these innovations. We want to innovate, but we also don't want to stray too far outside of our kind of comfort zone where you're taking on unnecessary risks, pursuing a few more % in performance.
Unfortunately, that is all we've got time for. So I just wanted to say thank you so much to all our speakers, Dan Su, Aaron Banana, and Dr. Mark Griffith. And thank you to everyone at home for all your questions and your participation. There were a few questions that we didn't get time for, but I guess that's just a sign of how interested people in Australia are about modules in the large-scale sector. Just finally, before we go, we have a new copy of PV Magazine International January edition. It's out now. It's pictured here, in some shameless self-promotion. There's an article here from Blake and I. And you can read those online as well at kind of any time. There's also some good webinars that we have coming up. They include understanding and mitigating the dangers of posed by hail and wind. That's on January 25th. And we also have reducing environmental impact of PV mounting structures on February 10th. Everyone at home will be receiving a survey at the end of this webinar, and we're obviously always looking to improve. So if you have a minute, we really appreciate your feedback with that one. There is a recording of this webinar, and you will receive an email link that will also include all the slides. We had a question in there about kind of reading some stuff off the slides. So that will be all made available to you guys. Thank you so much for joining us from wherever you are in the world, and all the best. Thank you. Goodbye. Thanks,
Thank you,
everyone.
Thanks.
See you.